Next up, we've got, we're going to skip down to Daryl, apparently. Daryl Dwyer is Associate Professor of Ecology at the University of Toledo, where he serves as the Director of Environmental Remediation and Restoration Lab. He's the resident faculty member at the university's Lake Erie Center, and his research interests include bioremediation, natural attenuation, and restoration. Daryl.
All right, thank you. And also, thank you for the invitation here. For the last 13 years now, my lab has actually been out at Maumee Bay State Park, which is the jewel of the Ohio State Park system. And we do the monitoring of the beaches so that we can tell when we have exceedances of E. coli. For the last 2 years, we've actually added microcystin to the monitoring that we do. And as part of this work, we've been trying to come up with models that are actually going to predict when these exceedances occur. As part of getting enough data for those models, we identified the proximal source of E. coli for the beaches, set up a monitoring system so that we looked at water quality and discharge starting in 2007 up through the current time, and we used those data as part of a GLRI project, a proposal that we had put in. And we had 4 different projects funded at about $2.3 million, I think it is. 2 of those are in that watershed, which is affecting the beaches. We put in a riparian restoration, which involved a large sedimentation pond for collecting sediment, followed by a subsurface wetland system. And in that wetland, we actually had limestone as a sorbent. Now, the grants back in those days were for E. coli because we were looking at one of the issues with our AOC, which was beaches and human health. But I snuck in that we could do phosphorus as well, and I guess I was really pretty lucky I did it at the time. So at any rate, we then monitored afterwards to see how well these systems are doing. And if I could just say something quickly here, because of the flashiness in this area, that we have, the riparian system, which is kind of like a 2-stage ditch and has that sedimentation pond in there as well, did not work very well during periods of high flow. And I mean by that if you take a look at the years that we've been doing our sampling, about 80% or more of the phosphorus actually comes through in a period of about 3 days every single year. And the water flow is so high and so rapid at that point in time that floodplain restoration doesn't do very well with the phosphorus. Does capture sediment. We've been taking out tons of sediment every year. This is a 17 square mile watershed that we're dealing with. But the phosphorus kind of going right on through. E. coli, maybe 40% of the E. coli is taken out, maybe 2% of the phosphorus. When we get down to the wetlands, we've seen a reduction of all of the E. coli and about 80% of the phosphorus through the wetland. And by our calculations, and people can argue with me on this if they like to because we're still looking at the numbers, we calculated that based on the wetland that we put in, 2,500 acres of wetland would be enough to reduce the 40% reduction that we're looking for in phosphorus in the Maumee River watershed. And but that's because we have that sorbent, which is present in there for doing that. And I had like 4 things I thought we might talk about, but I'm going to pass this on, if I may, pass it on.
Please.
And,
So
bring that up later.
Edwin is up next, and but again, I think it's like the second or third time we've heard about the importance of understanding the impact of storm volatility, right, and the pulse that comes with the intensity of the water that comes in the more intense storms that we're seeing more and more of. Okay, thank you, Daryl.